Good day, everyone. My name is Sharifi, and it's my pleasure to share with you today an exploration of randomness in order through the fascinating story of Paul the Octopus. Today, we will journey through science, probability, and philosophy, asking ourselves the profound question: is there a designer behind the universe we observe? Let us begin with Paul, a common octopus, Octopus vulgaris, that resided in the Sea Life Center in Oberhausen, Germany. Paul rose to international fame during the 2008 UEFA European Championship and the 2010 FIFA World Cup for his uncanny ability to predict football match outcomes. A simple creature became a symbol of randomness, defied a narrative that captured the world's imagination. Paul's predictions were based on a straightforward setup: two clear boxes containing food, each marked with the flags of competing teams, were placed in his tongue. Paul would choose by opening one box to retrieve the mussels inside. This simple act left people wondering, was it randomness or something more? In the match Germany versus Poland, Paul correctly predicted Germany's 2-0 victory. In the match Germany versus Croatia, his prediction was incorrect. Croatia won 2-1. In the match Germany versus Australia, Paul got it right again. Germany won 1-0. In the match Germany versus Portugal, another correct prediction. Germany won 3-2. In the match Germany versus Turkey, Paul triumphed with yet another accurate call. But in the final, his prediction failed. Spain defeated Germany 1-0. Out of 6 predictions in 2008, Paul was correct 4 times and incorrect twice. Moving on to 2010, Paul's predictions became even more extraordinary, correctly predicting Germany versus Australia 4-0 victory for Germany. And there was one wrong prediction, which was Germany versus Serbia. And this was the only one. But then on, Paul continued to his correct predictions. Germany versus Ghana, 1-0 victory for Germany. Germany versus England, a resounding 4-1 victory for Germany. Germany versus Argentina, 4-0 win. Germany versus Spain, 1-0 win. Germany versus Uruguay, third place playoff. Germany triumphed 3-2. And most impressively, predicting Spain's victory over the Netherlands in the final. Of the 8 matches Paul predicted in 2008, he was right 7 times and wrong only once. Combined with 2008, Paul's total correct predictions were 11 out of 14. Let's delve into the probability of randomness. Let us examine the statistics, assuming each choice is independent and has a 50% probability. The formula for the probability of n consecutive correct predictions is P of n equals to 1/2 raised to the power of n. Today, we explore the fascinating concept of randomness in order using Paul the Octopus as a case study. The research question is, were Paul's correct predictions due to randomness? The null hypothesis, denoted as H0, assumes Paul's predictions were random. The alternative hypothesis, denoted as HA, posits that Paul's predictions were not random. The formula we use to calculate probabilities is P of n equals 1 divided by 2 raised to the power of n. For example, for one correct prediction, the probability is 1 divided by 2, which equals to 0.5 or 50%. For two consecutive predictions, it is 1 divided by 4, which equals to 0.25 or 25%. As the number of predictions increases, the probability decreases exponentially. By the 11th consecutive prediction, the probability is divided by 2048, which equals to approximately 0.0488%. The probability is far smaller than the statistical significance threshold of 5%. Based on this, we reject the null hypothesis and conclude that Paul's predictions were statistically significant and unlikely to be random. Imagine walking into a room and seeing a bookshelf perfectly arranged alphabetically by author and by height. Would you believe this happened by chance? Let us test this hypothesis. The null hypothesis, or H0, assumes that the arrangement is random. The alternative hypothesis, or HA, suggests that the arrangement is intentional. Assume there are 10 books. The total number of possible arrangement for these books is represented by 10 factorial, which means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This equals to 3,628,800 possible arrangements. Out of these, only 2 are considered perfectly. One, where the books are in the alphabetical order, and the other is reverse alphabetical order. The probability of the perfect arrangement is calculated as follows. 2 divided by 3,628,800, which equals to approximately how many zeros? 55. Or 0.4055%. Such a small probability strongly implies that the arrangement was intentional. Just as the bookshelf needs an arranger, so does the intricate order of the universe. We are slowly delving deeper in them. Okay, so now let us consider a 2-line computer. Okay, we're going to assume a 2-line computer code with 80 characters per line. The code consists of 68 possible characters, which includes letters, digits, and symbols. The null hypothesis, or H0, assumes that code sequence is random. And the alternative hypothesis suggests that it is designed. The probability of selecting the correct character is calculated as follow. Okay, 1 divided by 68, which equals to approximately 0.0147 or 1.47%. For a single line of code containing 80 characters, the probability of arranging the line correctly is 1 divided by 68 raised to the power of 80. This equals to approximately 2.5 times 10 to the power of 147. For the entire 2 lines code, the probability is 1 divided by 68 raised to the power of 160, which equals to approximately 6.29 times 10 to the power of negative 294. These probabilities demonstrate how improbable it is to generate even a simple functional two-line code by chance. This strongly supports the necessity of intentional design. Every man-made object, from the simplest needle to the most complex airplane, reflects intentional design. Such order cannot arise from randomness, whether in our creations or the creation of the universe itself. DNA, the molecule of life, is composed of 4 chemical bases: adenine, thymine, cytosine, and guanine. The human genome contains 3 billion base pairs, and the specific sequence of these bases determines the functioning of the organism. Let us examine a short gene containing 100 base pairs. The null hypothesis in here again assumes that DNA sequence is random. The alternative hypothesis suggests that no, it's designed. For a sequence of 100 base pairs, the total possible arrangement are calculated as 4 raised to the power of 100. This equals to approximately 1.6 times 10 to the power of 16. The probability of arranging these bases correctly by chance is 1 divided by 4 raised to the power of 100, which equals approximately to 10 to the power of negative 16. This probability is astronomically small and far below to the statistical significance threshold of 5%. Such a result leads us to reject the null hypothesis and conclude that DNA's complexity strongly points to deliberate design. As such, intricate order cannot be attributed to random processes. Okay, let's ponder the scales. DNA is 11.76 billion times smaller than the human body. The human body is 7.5 million times smaller than the Earth. Earth is 109 times smaller than the Sun. The Sun is 754.8 billion times smaller than the Milky Way galaxy. The Milky Way galaxy is 838,000 times smaller than the observable universe. And so the DNA compared to the universe is smaller 44 quadrillion times, which is million times, 44 million times. Now, if randomness fails to explain such precision and complexity, then who designed it all? As we rejected the randomness and accepted the existence of a designer, now, can we agree on these attributes for the designer? All-knowing, the all-seeing, the sustainer, the truth, the originator, the restorer, the eternal. These attributes reflect a being beyond our comprehension, yet intimately connected to every detail of creation. The magnificent, the one and only who deserves our awe and gratitude. The Creator is not just a concept, but a reality we see through the order of existence. Peace be upon you all.